Now it's visible, sir.
Yeah, it's visible, and it is also changing.
Yeah.
Yes. Okay. So that is good. So that just to ensure that everything is
Yeah.
technically done. Okay. So you can only keep the title so that anybody can.
Okay. Yeah.
Okay.
Yeah.
Thank you. So we will wait just around 3 or 3:05. We will start. Okay. So
Okay.
let us join for some more people. We'll start actually.
Okay, sir. Yeah.
Okay. Okay. Aishwarya, now I think whatever personal, we can start now.
Okay, sir.
Yeah. So before this start, I also want to inform all of you that ICCS has notified some post of scientist. So it is already available in the ICCS website. So those who are interested, they can go to ICCS website for the details, and they can also apply, which is the online application. And last date for submitting this application is 8th December. So those who are here and interested, they should do apply as early as possible as per the details given in the notification. Thank you. So we will go to Aishwarya. Aishwarya, you can start.
Yes, sir. So good afternoon, everyone. I'm glad to welcome all to the 7th webinar of ICCS webinar series. So today's topic is Carbon Footprint Assessment and Net Zero Commitments for a Livable Climate by Dr. Sruthi K. Before moving on to the lecture, let me give you a brief introduction of our keynote speaker. Dr. Sruthi KV is currently the scientist in Center for Water Resources Development and Management. She received her PhD from Department of Earth and Environmental Science from Chonbuk National University, South Korea. She completed her BSc from Kanu University and MSc from Cochin University of Science and Technology. Prior to working in CWRDM, she served as scientist in Korea Institute of Geoscience and Mineral Resources, National Institute of Hydrology, Roorkee, and as postdoctoral fellow at Chonbuk National University of South Korea. She was awarded with fellowship from International Association of Hydrogeologists, who has demonstrated the highest level of excellence and innovation on the work. Currently, she is working on carbon footprint assessment, climate change impacts on water quality, and saline water intrusion modeling of coastal aquifers. So without much delay, let's move on to the lecture. I request all of you, other than the speaker, to kindly turn off your video and audio. You can also watch the session live on YouTube by streaming onto the official YouTube channel of ICCS. Now, let me welcome Dr. Sruthi KV for delivering the lecture. Over to you, ma'am.
Okay, thank you very much, Aishwarya. Thank you very much for the nice introduction. So I'm also not taking much time for any other kind of information. We will move to the lecture series. As you all know, this is ICCS monthly online lecture series as 1 month, 1 theme initiative, and it's a webinar 7. And today our topic is on carbon footprint assessment and net zero commitments for a livable climate. So this is our topic today. So we will be discussing more about the carbon footprint assessment and what is net zero and what are the net zero commitments from our side and how can we achieve this. So how can we measure this carbon footprints also? Also, how can we know whether we are in a net zero status or not? So these are the main points we'll be discussing during this lecture. So this is about the overall lecture. Why is carbon footprint assessment is significant? Why is net zero commitment is important? So as I will start with our COP27, which is concluded recently. So you all might have know about COP27 was hosted by Egypt, and it happened in November 22nd at Sharm el Sheikh in Egypt, and the COP, Conference of Parties. It stands for Conference of the Parties, and this is a meeting which happens annually to try to forge a global response to the climate emergency. So I am discussing about COP because when we discuss about this COP and COP27 meeting or COP26 meetings, you will be getting the idea why we need to commit for net zero status, or what is the importance of carbon footprint understanding, or what is the importance of carbon footprint assessment in a country scenario, or you can tell the regional scenario, or even the micro-regional scenario. So you will understand the significance of both of this during the discussion of COP or COP27 or COP26, which happened last year. So as we already discussed, what is standby COP and where it happened, and almost 120 world leaders attended this time the COP meeting, COP27. And COP27, it happened in Sharm el Sheikh recently, and focusing on following through of COP26, which happened in Glasgow in last November, that means 2021 November. We have taken some ambitious new goals during COP26. That is, countries agreed to limit global temperature rises to 1.5 degrees Celsius. We cannot exceed that limit. So that is one of the ambitious goals we have taken during COP26. So what COP27 is doing is whether we will be able to achieve it or whether we are acting towards it. So that's what we discuss this time during COP27. So this is the major thing we need to understand. Now we will move to more details, like why we need to keep the global temperature 1.5 degrees Celsius, why this global temperature is increasing always, what are the reasons for the increase. So you will get an idea why we need to commit to net zero. So let's move to next slide. So this was the final conclusion from COP27, that is, we must act now. Instead of so many suggestions, it's the time to act now. Then only we can limit our temperature rise into 1.5 degrees Celsius. So now we are moving to why this 1.5 degrees Celsius, why it is not 2 degrees Celsius or more than that. Why is it 1.5 degrees Celsius? So we need to understand that the Intergovernmental Panel on Climate Change, IPCC, has examined closely what a 1.5 degrees Celsius how it can impact the atmosphere, and also what a 2 degrees Celsius rise how 2 degrees Celsius rise, how it can impact our planet. So they have done this comparison. So it means that 1.5 degrees Celsius is more favorable than 2 degrees Celsius rise. So I will be going to the kind of impacts we will be facing when the temperature increases. You can see in the next slide. So what we need to understand is there is still a chance that we can stay within 1.5 degrees Celsius, but we need to act now. Then only we can be in 1.5 degrees Celsius temperature increase status. Otherwise, if it is increasing by 2 degrees Celsius rise or more than that, it will be irreparable. We won't be able to come back to our natural system or natural status or whatever the environment we have. So the earth will be in a non-livable situation. So we need to make the Earth's atmosphere or Earth's climate stable to a livable climate. That's what our goal or our aim by focusing on net zero commitments. So let's see what are the impacts. So the impacts at 1.5 degrees Celsius, still it means there will be a rising sea levels. If there is a rising sea levels, so many of these coastal countries or coastal island kind of countries will be underwater or under sea, and there will be bleaching of coral reefs in our ocean, and there will be ocean acidification due to this 1.5 degrees Celsius rise or even more than that. And also it can lead to extreme weather in terms of heat waves, droughts and floods, and even the storm intensity. But what we need to understand, what we need to realize is the effect of 1.5 degrees Celsius are manageable compared with 2 degrees Celsius rise. So we need to control our temperature rise not to be more than 1.5 degrees Celsius. This is what our goal, and this is what we have to do. And now we will go to how we can achieve this and what is the reason for this kind of increase. So let's move to next slide. So now we'll see where are we now. Right now, we are currently around 1.1 to 1.2 degrees Celsius above pre-industrial levels. And greenhouse gases are still increasing, which are the reason for this kind of increase. We'll be going to more detailing how these greenhouse gases are the reason for increasing temperature of the atmosphere. So what you need to understand right now is we are in a situation of 1.2 degrees Celsius rise of temperature compared with pre-industrial levels, and greenhouse gases in our atmosphere are still increasing. That means it is due to the anthropogenic activities. This is what we need to understand right now. And carbon emissions decreased during COVID lockdown period, but studies shows that it has started to increase again as economy recovery. So this is what happening right now. And we need emissions to decrease by 7% each year until 2030. Then only we can achieve this 1.5 degrees Celsius temperature target. Otherwise, it will be going more than that. So we need to really act now. Otherwise, it will be difficult for us to recover back our Earth. So this is a climate crisis. But what we can see is still there are so many countries, they are utilizing the coal plants for their energy purpose and even the fossil fuels. At the same time, what happens, the other countries, they are hit by catastrophic floods, droughts, wildfires, and all other natural calamities. So we need to take the responsibility, like how can we utilize non-fossil fuel energy, or how can we utilize non-renewable energy other than this fossil fuels for our purpose, so that we can definitely reduce our carbon, or we can definitely reduce our greenhouse gas emissions. So this is a climate crisis, and we all need to be aware of what is happening exactly, how this climate crisis has happened, whether it is due to the natural part only, or whether we also involve. That means anthropogenic activities also included. Definitely we know because of the anthropogenic activity is the main reason for our global warming and more greenhouse gas emissions. Now, we don't need any evidence right now, because we already have several evidence from Kerala itself. But even we have the not only from Kerala, we have the evidences from different parts of the world. We have the evidence from Pakistan. We have the evidence from Nigeria. Recently happened floods in Nigeria, and so many evidences in the world level as well as in ourselves, in the state level as well as regional level is existing. So we need to be. We don't have to show any more evidence that climate change is happening. It is happening in front of our eyes itself, in terms of flood, in terms of storms, etc. So this was about what are the losses happened during our Kerala's worst ever flood. During 2018, we have almost 220,000 people displaced, 400 people drowned or buried, and it was the worst flooding instance in 100 years, and 20,000 homes destroyed, and almost economic damage was in 2.8 billion USD. So this way, the effect of this climate crisis, or you can tell it as climate change, and these are the losses we have faced during this kind of natural calamities. So if we are not acting to consist our temperature, or consist the global warming in a particular level, or limit the global warming, we are going to face this kind of natural calamities and losses in frequent ways. So we need to be careful, and we need to act right now. We all have to act right now. So as a part from our side, as a researcher or as a student, or you can tell even as a citizen, you can think as, at least we need to understand what's our carbon footprint and how can we contribute towards this net zero commitment. So this is what you are going to understand from next slide. So these are the losses happening because of the major calamities or major natural disasters. So this is the example from Kerala, and this pic shows, this is an example from Nigeria during the flood, and there are several cases reported from different parts of the world. So that is an introduction for you, and also now you might be understood what is the importance of achieving net zero commitment, or what is the importance of understanding the carbon footprint of yourself or your institute or your region or your state, whatever the system is. so that you can just try to make it at net zero. If you know the carbon footprint of yourself, you will understand how you can achieve this net zero. So now we will move to the basic concept of what is net zero, or even we tell sometimes it as carbon neutral. Net zero or carbon neutral is to stop uh, emitting the carbon dioxide and other greenhouse gases. This means stopping the burning fossil fuels and finding ways to farm that don't release methane, etc. At the same time, not only the stopping, or sometimes we always know that we cannot completely stop our economic activities. We need to, at the same time, when we are emitting the greenhouse gas or the carbon dioxide, you need to find a way to reduce it. Not only reduce it, you need to find a way to absorb it from the atmosphere. That can be a forest, that can be a reservation of peatlands, conservation of wetlands, etc. So, which can store vast amount of carbon to offset this emission. When your emission and when your sequestration, that's what in scientific term we call for carbon absorption from the atmosphere. When this come equal, when these two emissions are when this emission and sequestration is equal, you can tell that your system is in a net zero status or carbon neutral status. So this is what this balance is known as net zero. So whatever input, whatever the carbon input you are giving to your atmosphere, you need to have a way to take it out from the atmosphere. Then only you can keep this balance. If you have this balance, you can tell that you are in a net zero status. It can be your institute, it can be ICCS, or it can be the Kerala state. But this is not a simple thing that to achieve net zero. So we will see what are the complications and why we are not able to do that in a constant way, why some of the countries are a little bit hesitant to commit towards net zero, etc. We will see that. So this is the concept of net zero, a balance between emission and sequestration of greenhouse gases. So this is a simplified version or simplified representation of carbon neutral or net zero. That means you have the emission in your system and sequestration in your system. If these two are equal, you can tell that your system is in a net zero status, or it is or net zero or carbon neutral. And at the same time, we can see what is carbon footprint also. If you have the data of emission, for example, I will tell you, if you have the emission, how much emission is happening from ICCS, and how much emission is happening from, how much sequestration is happening in ICCS. If you have these two data, you can understand what is your carbon footprint. You just have to add it up. When you add these two, if the value is negative, the system or the institute is in a carbon negative situation. If it is positive, it is carbon positive. If it is equal, if it is zero, that is in a balanced situation, emission equal to sequestration, then it is in a carbon neutral or net zero situation. So this is what you need to understand, what is meant by carbon footprint and what is meant by carbon neutral or net zero, or even carbon positive and carbon negative. So this is what this is the basic concept about this. Now, what kind of emission causes this kind of 1.5 degrees Celsius of temperature rise, or the global warming, you can tell generally. So as the picture shows, it is the greenhouse gas emissions. And what is greenhouse gases? Greenhouse gases, simply the definition is any gas in the atmosphere which absorbs and re-emits heat, which can absorb as well as re-emits heat, and thereby keeps the planet's atmosphere warmer than it otherwise would be. So the particular gas which can absorb and re-emit heat to the atmosphere of the Earth, and the planet's atmosphere will be warmer. So you need to understand that there will be it is needed to have some greenhouse gases in our atmosphere to keep our atmosphere warm and in a good situation, in a livable situation. That's what greenhouse gases do. But if there is anthropogenic interference, that is human interference, which contributes more greenhouse gases, that will have a negative impact to our Earth, and the situation will be non-livable. So this is what we need to understand, the second point. Now, what are the major greenhouse gases in our atmosphere? These are the carbon dioxide, methane, and nitrous oxide. They are the major greenhouse gases, and other gases are in the trace amounts comparatively, and also they have the cycle also, hydrological cycle, carbon cycle, etc. are there. If those cycles are destructing by the human activity, then only all the kind of problems to the atmosphere is arising. This is what we need to secondly understand. Now, when we talk about this carbon emission, sequestration, those are the terms, scientific terms we need to know during the calculation of carbon footprint. And there is carbon sources and sinks. What does it mean by a carbon source? This is from its name itself, we can understand that carbon sources will be, it's a source of carbon. So wherever, what causes the emission, that is the carbon source. And what causes the absorption of carbon, greenhouse gases or carbon from the atmosphere, that is sinks for the greenhouse gases. So these are another two scientific terms for emission sources and sequestration sources, that is carbon sources. We call it as carbon sources and carbon sinks. And here in this picture, you can see that the fundamental reasons for carbon emission, or you can tell it that what are the carbon sources and sinks in our nature. So you can see here, definitely the transport will be one of the carbon emission reason, or you can tell sources of greenhouse gas emission, and also the firing, and you can see here waste, and also the cultivation, agriculture. These are some of the reasons for the carbon emission or greenhouse gas sources to the atmosphere. And what are the sinks for this carbon dioxide from the atmosphere? You can see here the trees and also the soils, which can store the carbon in the form of soil carbons. And these are the major sinks for greenhouse gases which exist naturally. So these are the major sources and sinks which is reason for greenhouse gases. Now, whether all the greenhouse gases have similar impact or not. That's what next we are going to discuss. We should know that all the greenhouse gases does not have similar impact. It has different impact. That's what we call global warming potential. Global warming potential of each greenhouse gas will be different. So what is global warming potential? Global warming potential is the heat absorbed by any greenhouse gas in the atmosphere, which is a multiple of the heat that would be absorbed by the same mass of carbon dioxide. It means if you have the carbon dioxide and also another greenhouse gas, I will take methane. If you have methane also, one molecule of carbon dioxide and one molecule of methane in the atmosphere, then what you can see is methane has 28 times more global warming potential than CO2. If CO2 makes 1 time global warming, CH4 makes 28 times than CO2. So we can express whether these greenhouse gases have similar impact. We need to understand definitely it is not. Each greenhouse gases is having different global warming potential, and it is expressed in terms of or times of CO2 warming impact. So CH4 has 28 times warming potential than CO2. If you're taking nitrous oxide, it is having 298 times higher global warming potential than carbon dioxide. So this is what meant by global warming potential. So for other gases, it depends on the gases and also the time frame. The time frame in the sense residence time, how much time it exists in our atmosphere. And global warming potential is 1 for carbon dioxide always. That's the standard we use to compare the global warming potential of other greenhouse gases. Now, you might have heard we always express our greenhouse gas emission in terms of equivalent carbon dioxide. Why is it doing like that? Because if you have some amount of methane and if you have some amount of carbon dioxide, if you have some amount of nitrous oxide, you will not be getting a cumulative amount, or you cannot be able to add this. So we need to make it into a common unit to add up this and understand what is the ultimate carbon footprint. So this is why we use the unit equivalent carbon dioxide. You can convert each greenhouse gas into equivalent carbon dioxide unit. So equivalent carbon dioxide is the amount of global warming caused by a quantity of greenhouse gas at a specific point in time, which is expressed in terms of the amount of carbon dioxide which would have the same instantaneous warming effect. That's what we already discussed. So if you have 1 molecule of CO2 and 1 molecule of CH4, you have 2 greenhouse gases. But you cannot tell that I have 2 molecule of greenhouse. I have 2 gram of greenhouse gases. You cannot tell it. Instead of that, what you will do is you will convert this methane gas in terms of equivalent carbon dioxide. So 1 molecule of methane is equivalent to 28 times global warming. So you can make if you have 1 molecule of CO2 and CH4 1 molecule, then it will have an impact of 29 equivalent carbon dioxide global warming potential, or 29 equivalent carbon dioxide will be your carbon footprint. This is a unit or common unit we need to consider for greenhouse gas concentration expression. Now, we will see what are the greenhouse gas emission scenario or greenhouse gas emission from key socioeconomic sector. This is a global scenario. We have taken in global scenario, energy has the highest greenhouse gas emission. Energy sector has the highest greenhouse gas emission. It is 35%, followed by industry, followed by transport is 13%, and later on agriculture, forestry, which is 11%, and ultimately is the waste. It is 4%. This is the global scenario. When we come to the national scenario, it's the same kind of trend you can see here. Energy, electricity, and heat producers, the energy has again the highest greenhouse gas emission. Energy sector is the reason. And second one is the industrial sector. Third one is transport sector. And next one is other energy and residential sector. Later on, it comes to agriculture and waste sector. So this is the national scenario. Now we have understood what is meant by net zero and what is the importance of net zero, and how can we measure, how can we understand our system is net zero, and we need to understand what is the carbon footprint. Then only whether our system is net zero or not, it will be clear for us. If we need to know the carbon footprint, then only we can understand how much we have to reduce to reach to the net zero status. So now what we are going to see is the basic concept about carbon footprint, as well as what is the methodology we follows for carbon footprint assessment. We will see that. So carbon footprint. So we have already discussed. It's a measuring and recording the greenhouse gas emission of an organization or sector within a defined system boundary. So it means that you need to this is the measure of your carbon emission from your institution. It can be from your institution, or it can be from different sectors, like we have mentioned before, like transport sector, waste sector, agriculture, forestry, and other land use sector, energy sector. It can be any sector. What is the carbon emission? That's what we have meant by carbon footprint of the system. So within a system boundary will be within the system boundary. For example, if you want to if you want to estimate the carbon footprint of ICCS, you know what is the boundary of ICCS, what are the activities happening inside ICCS for which causes the emission, and what are the sequestration sinks which available in ICCS. So within that boundary, you can estimate your carbon footprint, and you can identify that what is the carbon footprint status, or what is the carbon status, whether it is carbon positive or carbon negative. If it is carbon positive, which area you need to reduce more, whether you need to reduce the energy utilization, or whether you need to have a good waste management system. You need to understand. You can understand that if you know the carbon footprint from the sectors, different sectors, for your institute or organization, or even the sectors what we have discussed. So carbon footprint is the total greenhouse gas emission which can be caused by an individual, event, organization, service, place, or product, which is expressed, as we discussed before, carbon dioxide equivalent. This is what the carbon footprint meant by carbon footprint. Now, we will move to, we understood the concept of carbon footprint. Now we will move to what is the methodology we uses, the basic or standard methodology we uses for the carbon footprint assessment. It is IPCC 2006 version. That is the first one, not first one. It is updated in 2006 and 2019. And Intergovernmental Panel on Climate Change. They have given methodology to estimate the carbon emission or carbon footprint from different sectors, like transport sector, energy sector, agriculture, forestry, and other land use sector, and also the waste sector. These are the sectors we can utilize the IPCC for estimation of carbon emission. So this is the basic methodology we uses, and the equation, the basic equation for any kind of emission, whether it is from transport sector or the basic equation is activity into emission factor. So we need to understand what is activity and what is emission factor. Activity is based on the activity or the action which causes the emission of carbon or greenhouse gases. Emission factor means each activity can contribute certain amount of greenhouse gas emissions. So we need to have that. So for example, if you have 1 liter petrol, how much it can emit? That will be some constant value. So that kind of emission factor, we need to estimate those emission factor in regional level, or what is the boundary we are choosing. We need to estimate according to that. So if you have these two data, activity and emission factor, you can know your greenhouse gas emission from your interested part or from your system. So activity, for example, I think we will be coming in the next slide. What are the examples for activity data and what are the examples for emission factor? Next, at the same time, if we want to calculate the carbon footprint, we need to have the sequestration also. So sequestration means what are the sinks available in your within your boundary, whether it can be a forest, whether it can be a wetland. So you need to understand what are the sectors which act as a sink. You need to have that data and sequestration factor. It means, for example, a tropical forest. If you are taking an area of tropical forest, it has certain capacity to absorb carbon dioxide that can be utilized as sequestration factor. Another example, if you are taking for rubber plantation, that rubber plantation will have particular sequestration factor. So you can utilize that for the calculation. So you need to have what is the type of sinks available for the carbon absorption or carbon sequestration in the area, and you need to have the data of sequestration factor also, so that you can calculate this what is your sequestration. This we are following the IPCC methodology. Now, usually when we calculate the carbon footprint or carbon footprint assessment, we concentrate in these five sectors, five key socio-economic sectors like energy, transport, agriculture, forestry, and other land uses, livestock sector, waste sector. These are the sectors we consider for emission calculation. And sequestration, we take whatever the sinks available in your area, whether it's a forest, whether it is a just normal rubber plantation, whether it is a mixed crop region, or whatever the kind of sinks available in your area, you can utilize that data for sequestration calculation. And there will be carbon stock also. For example, in the soil, this carbon will be stored for a long time. It doesn't happen in 1 year or 2 years. So that kind of carbon stock from soil will be calculated. So that cannot be utilized as a sequestration because it is stored in a long period of time. So that can be considered as a carbon stock only. But sequestration is mainly happening through forest, wetlands, and peatlands, other kind of grass, even grasslands, and other kind of vegetation. So this is what we need to understand. So if we take your energy sector, you need to understand what is the energy you are utilizing, whether it is electric energy or whether it is any fuel energy you are utilizing. You need to have that quantity. Then that is your activity data. When you are utilizing the energy, how much is the emission? What kind of activity? If you are using electricity, how much emission is happening? So your activity data is quantity of electricity you have utilized. So this is how you need to understand the activity data. This is for energy sector. For example, if you are going to utilize per month, so that is your activity data. Utilization of petrol is leading to the greenhouse gas emission. So if you have that activity data, you can definitely calculate what is the emission from transport sector or what is the emission from your car during a month. So you can do it in this way. For this is the same thing we can apply for in a micro regional level. The same equation we can apply for in a regional level. Same equation we can apply in a state level, national level, etc. So this is what happening. Now, if you want to go for the agriculture and forestry sector, you need to understand what are the kind of emission and sequestration sources in the agriculture sector. Definitely, you will be knowing that in the agriculture sector, there is paddy fields. Paddy fields have some kind of methane emission. So you need to have that area of paddy field. how much is the emission from CH4 emission from that paddy field, and also there is a probability of uh, emission from utilization of fertilizers, whether it is chemical fertilizer or organic fertilizer. So if you are utilizing organic fertilizer, your emission factor will be different. If you are utilizing the chemical fertilizer, the emission factor will be different. So you need to have this kind of data for the calculation of carbon footprint from agriculture sector. So, and also what kind of land type is present there. So if you have that, it means you need to make a list or make a chart of what are the activity data or what are the activity leading to carbon emission from this particular sector. According to that, you can calculate the carbon footprint from particular sector. Now, if you're going to the livestock sector, livestock means it is a different kind of our animals, livestock animals such as poultry is there, and swine is there, and also sheep, cows, extra comes into livestock. So each livestock, for example, cows will be having different kind of emission pattern. The same way, poultry will be having different kind of emission pattern. So you need in this sector, we usually take number of each livestock. That means how many of cows you have, how many of goats you have, how many of poultry you have. So this is the activity data. And also at the same time, in the livestock sector, there is the waste management issue also. I cannot tell it's an issue. There is waste management calculation also. That means the waste from the livestock also will be taken as an activity data for carbon emission calculation. So this is about livestock sector. And when you come to waste sector, you will be thinking about, you need to understand about whether it is a solid waste, whether it's a liquid waste, that we are coming in the next slide detailing. So, and also sequestration, as we have already discussed, you need to have the type of area, whether it's forest, how much forest is available. If you need to have all those data. That is your sectoral data for sequestration, and you can calculate what is the sequestration, what is the carbon absorption from the atmosphere due to a forest, due to a wetland. That also can be counted in that area. And carbon stock, it is from the soil. Mainly, what is the soil? Organic carbon. That is the carbon. This way, you need to modify according to your need, according to your sector, according to your boundary, the methodology. So this is how we can apply the IPCC methodology for the carbon footprint calculation in particular area. It's up to your interest. So this is an example I am showing here, which we have done recently in one of the legislative assembly constituency in Kerala. So what are the activity data we have collected during the calculation of carbon footprint from energy sector? So this LAC was consisted of almost 6 panchayats. So we have collected the diesel, petrol, energy. What are the energy kind of energy utilization in these all panchayats happening, and what is the quantity of these fuels they are using for energy purpose. So this is the activity data example. I am showing an example which we have collected. And in the case of transport, you need to have number of vehicle per type. Actually, in transport case, you can calculate the carbon emission in 2 ways. Like you can utilize the quantity of fuel utilized, or you can come into a term of number of vehicles per type, and what is the distance traveled, and what is the emission factor. This is the same emission factor we are giving for different kind of vehicle type. So this is the equation. You need to have the number of vehicle, distance traveled, and emission factor for that particular vehicle, so that you can calculate the emission from the transport sector. Same time, you can utilize the different equation. That is you need to have the quantity of fuel utilized and emission factor for that particular fuel. You can adopt two of this method. So, and now, when you come to agriculture, forestry, and other land use sector, the carbon footprint assessment, here you can see that different types of agricultural fields are present. So you need to understand what kind of agricultural lands are present there. And you need to understand what is the energy sources used there. What is the fertilizer used there? You need to have the activity data list. That is the first part, which this we have already discussed. Now, this is an example how we calculated the carbon footprint for agriculture sector. Here we have we have utilized the chemical fertilizer, and this is a different kind of agricultural area or cultivation area present in that particular region, and we need to have that how much area is covered by each kind of cultivation and how much is the chemical fertilizer they have utilized. So if you have this data, you can utilize the equation for agriculture carbon footprint assessment calculation. Now, this is about the waste sector calculation, how you can calculate the carbon footprint. So you will have two kinds of waste, solid and liquid waste. And in solid waste itself, there will be non-biodegradable and degradable one. The emission factor for these two will be different, so that you need to have how much non-biodegradable waste were there, and also how much degradable waste were there. Same way, you need to have quantity of liquid waste also. And the liquid waste factors, emission factor for industrial liquid will be different. Emission factor for domestic liquid will be different. So first, what you have to do is you need to collect the data, that is activity data, which will be the quantity of each waste produced. This is how we calculated the emission for this waste sector. So you need to have the fraction of population and what is the organic waste produced, and if there is any kind of discharge pathway or any kind of treatment they are utilizing. So according to this data, this activity data, you can utilize this equation, which is in IPCC, so that you can calculate the emission from waste sector. Now, this is about sequestration. This we have already discussed. What are the different kind of sequestration sinks available? It can be a forest, wetlands, even the homestead trees can absorb some amount of carbon dioxide. That can also be counted for sequestration calculation. And how much is the soil sequestration? For that, you need to understand type of soil, whether it is a lateritic soil or whether it is any other kind of soil. So if you have this kind of data, you will be able to calculate the carbon sequestration through soil. And ultimately, what we got, we have calculated the carbon emission or carbon emission from different sectors. That data we have, and also we have calculated the sequestration data also. So finally, you can sum up these two, and that will be your carbon footprint. This we have already told before also. Now, this is one of the case study. We have applied the same methodology, IPCC methodology. This we have done in one of the LAC in Kerala. What we could see is almost 78.4% of their emission is existing in the atmosphere. Only 21.6% is getting absorbed. If they could make it to 28.4% more absorption, then they can tell that it is in a net zero status. Right now, they are working on this part to get it to reduce the excess carbon to 50%, so that it will be in a net zero status. And also, we have done for different socio-economic sector for them, in transport, energy, agriculture, forestry, other land use sector, livestock, waste sector. So it can be seen from this calculation that energy sector had the more emission in this LAC, followed by waste sector. So they are now they are working on the waste sector to eliminate the emission from the waste sector completely. So they are working on that to reduce. So what does it mean? It means that if you know which sector has more emission, you need to make the strategy to reduce the emission from that particular sector. So this is the importance, or this is the importance on calculating carbon footprint, or this is the importance of carbon footprint assessment to understand and to act towards what exactly need to achieve net zero or carbon neutral. And this is another study we have done in Kozhikode. What you can see here is, in this study, energy has highest, and second part is transport. But in this region, energy is the highest, and second one is waste sector. So according to the activity, or according to the region, micro-regional level, the scenario is different. So that the strategies, we cannot apply the common strategy for every places to reduce carbon emission. We need to have the particular or unique strategy for different regions according to their emission patterns. Now, we have understood the carbon footprint and how can we apply the carbon footprint assessment for our purpose. And we have understood those parts. Now, we need to understand what are the solutions may be available for us. First, we should always depend on nature-based solution. That means preserving and restoring existing forests, peatlands, wetlands, etc. Those are the natural carbon sinks. And also
Dr.
the
Sruthi.
Yes, sir.
Dr. Sruthi,
yes,
just
sir?
I want.
Yeah.
Can you complete it by in 5-10 minutes?
Yeah,
so that we can have a more, the question answer session also.
Yeah. Okay, sir. Yeah, I will complete it.
Okay.
Yeah.
Yeah.
Okay. Yeah. So this is about the nature-based solution. So this is one of the preferable method, or we always recommend nature-based solutions for this kind of net zero commitments. That's what recently happening, or you can see in COP27 discussion also, whether afforestation is possible. All those kind of things were it happened during the discussion. So you can see here, if you are not, how much you can absorb the carbon dioxide, how much you can reduce the carbon dioxide or greenhouse gas from the atmosphere. If there is non-destruction of forests, existing forests, wetlands, grasslands, then it can store or it can absorb almost 4.1 billion tons of carbon or greenhouse gases. If you are doing a smarter farming and in smarter energy techniques, using the smarter energy techniques or any other kind of smarter farming, and also using the forestry techniques, you can absorb or you can reduce 9.1 billion tons of greenhouse gas. And if you are restoring the forest and wetlands, which we have lost already, if we can do that, it can store totally the first one, second one, and the third one is the restoration. It can store almost 11 billion tons of greenhouse gas from the atmosphere. So it is just 1/3 of the emission what we need to reduce to achieve our 1.5 degrees Celsius. So it means we need to act really. We need to act more thoroughly, and we need to act with more strategies. And this is the overall of what we have discussed before. And also we need to have the funding adaptation also. According to the changes, according to our needs, we need to have funding adaptation. And climate adaptation, definitely we need if we have to change the location and all those kind of things. Different scenarios are there. So we need to do the climate adaptation also. So overall, what we have discussed before, carbon footprint assessment, etc. Why we discussed, that's what we could see from this overall lecture. That is, achieve net zero by 2070, which we have already committed with in COP26, and reducing total projected carbon emissions by 1 billion tons starting now till 2030. Increase renewable energy utilization 50% of our total energy requirements by 2030, and reducing carbon intensity by 45% by 2030, increasing non-fossil energy capacity to reach 500 gigawatt by 2030. So this should be in our mind, and this is the target, and we need to work towards net zero commitment. Not only the country level, even the regional level, even the individual level. Then only we can achieve this target. It is not an easy target, as we already discussed. This is about the net zero emissions and carbon footprint assessment, and what are the basic solution for achieving this net zero commitment. This is all about this presentation. Thank you very much, sir. Thank you very much for the opportunity. Yeah.
Thank you, Sruthi. Very nice lecture on carbon neutral assessment. So you had explained starting from why that 1.5 degree concept is very important.
Yes, sir.
What will happen if that goes to 2 degree, and then a very basis about about carbon footprint, carbon neutral sequestration, all that, and also what are the sources, sinks of that. And then you also showed an example how to calculate, this making a carbon neutral assessment. So overall, it was a very interesting and informative. I think that many of the things I also learned many new things out of that, and I'm sure whoever present here as well as looking through YouTube, they might have learned a lot. So now it is open for questions. Anybody, those who are any questions on this topic before I ask question. So I will give opportunity those who are listening to that for their question. Anybody?
Hello, ma'am. Can you hear me?
Yes, Sinan, I can hear.
Yes. Okay. It was really a nice presentation.
Thank you.
But I had a doubt regarding one of the methodology. I wanted a clarification. Is it, for example, when you're calculating the emissions, is it just based on a few samples, or you're actually having the data on the entire population?
Actually, that's what we were discussing about the boundary. So whatever the boundary we are choosing, inside that one, we need to have the data. It is not for the entire population. For example, I will tell you, I have taken the Legislative Assembly constituency. So for that particular calculation, we have taken the entire population of that Legislative Assembly constituency.
Okay. Fine. My doubt was that somewhere we have calculated the total amount of petrol and diesel and all. Is that the total amount within that boundary, or we have sampled and interpolated to the total population?
Actually, this is the data we have collected from different petrol pumps in that particular LAC. So that is how we have utilized that data for that LAC pump. Okay. So that is about the petrol or diesel. We have utilized the data from different agencies. So that's how we have collected that data. So for example, another one, if you are going for the waste sector, you can see that we have taken the amount of solid waste. That actually we have interpolated the data for the population.
Okay. That was my doubt.
Okay.
Thank
So,
you.
but if you have really, you can collect with a survey and all. That will be better to have a solid data or ground truth data for the calculation. But since we depended on different government departments for different data, for example, the energy sector, we have depend on the different petrol pumps and even the Indian Oil Corporation. We have collected the data from them. And the waste sector, we have depended on the Shujitva mission of Kerala government. So they were the people who availed the data for us during the calculation part.
Okay, ma'am.
Yeah. In fact, Shruti, it was a nice question from Sinan. In fact, I think that one slide with, source each data with from where, how you collected and all maybe a good, informative. Perhaps in future presentation, I think.
Yeah. Okay.
And similarly, in your instead of going to petrol pump separately, you also can have, Indian IOC or each agency, whether that
BPCL,
is possible to explore, because we are not sure each petrol pump, how they may give you data. And similarly, data, I have a general curious question, maybe a foolish question. So you can see that if you kata somebody petrol filling from there, and then going to somewhere else. So how we can, we cannot say that it was a source, but maybe just we can say.
Actually, sir, this is the question everyone asks when we have done this. But whatever the petrol they have filled from Katakada, it is going to emit somewhere. So at least someone should take the responsibility of that particular emission. So that was our defense when someone asked this question. Yeah. So this many people asked during our discussion many times. Yes, sir. Yeah.
Okay, that's great. Divya, you can. Dr. Divya.
Thank you, sir. Thank you, Shruti. Thank you for this wonderful lecture. I think you know me. I am your junior in Cochin University.
Yeah, I know you. Yeah.
I have a question. Like, are you assessing this carbon footprint on an annual basis? Suppose an area is recorded this much amount. What is the change in next year? Or if we are applying some measures like to reduce, whether it is working well or whether it is increasing? Are you doing such type of assessment?
Yeah, actually, right now we have done for one LAC and another panchayat. So in that LAC, we right now we have done the baseline assessment. So right now they are working on the waste management part, how they are doing different kind of activity. Like waste collection and waste recycling, etc. They are working on that. So next year we will be doing an interim assessment for whether they could reduce how much amount they could reduce. So we will be doing that next time. But this is the first time we have done this kind of study here. So next time we will be doing the assessment. Yes.
Thank you. That's a very wonderful initiative. Thank you very much.
So, in fact, the lecture that while we conducting, we also expect that, various people understand each of the scientists what they are doing, and then future, actually, wherever possible, people can go for a collaboration because they should know what the other person is doing. So, in fact, this type of online lectures helps people to understand, and you will find that many people are somebody working in agriculture, somebody with mud data, somebody is doing pollution. So we should also, explore the possibility of people coming after knowing that you can always contact, each other. And while anybody, if you need any contact of a presenter or those who are there, it is always ICCS can help and we can arrange those type of things. Okay, anyway, while saying that, any other question? Anybody else? Okay. So I think I have got one or two questions, very simple question. See, you had sectors like transport and energy, So you are, again, the diesel and petrol, that goes to vehicle maybe. So how you are distinguishing, energy in petrol and diesel used, and then do you say that petrol used to generate energy separately and used for transport separately? How do you distinguish that?
Yeah, actually, energy, that part we are mainly considered this KSCB, electricity one, and LPG. And this petrol and this diesel, mainly I have include fuel energy, that is for transport.
Okay. Similarly, you have got several kind of trees, like a coconut tree, rubber, etc. How do you get this number? Even you need a number. So how do you get that? So anybody keeps. My curiosity is that whether any taluk office or any panchayat office, they maintain those type of record, and also that coefficient of emission that you compute. Can we say
actually,
that same for everything?
Yeah, actually, this data, how much is the plantation area for each type? Like it can be coconut or rubber or many plantation were there. This we have availed mainly from the Kerala State Land Use Board. So they have the data of what kind of land use pattern and what is the area of land use available in different region. Like they have in LAC level also. So that is where we have received or we have got this data. We have availed this data of different land uses and emission factors. We have collected from different literatures also, not only from IPCC. IPCC is giving the data for emission factor for some of the species, not every species. And we have collected the literature data. For example, rubber plantation, we have utilized the emission factor data from Rubber Research Institute. They have that emission factor or coefficient of emission for this rubber plantation. And different literature we have cited for this kind of land use pattern emission or land use sequestration calculation.
Great. So in Kerala, which tree is best for carbon sequestration?
Actually, mainly people always recommends the forest, but we don't have that much area at all for foresting the particular part. So people goes for Miyawaki forest kind of things. It is like mixed species. We always recommend the mixed species kind of area for more carbon sequestration.
So like a pine tree or, even you can have a mangrove. I just, people want to, in fact, develop some kind of even forest means that which tree may be preferred.
Yeah, like it depends, like mainly they utilize this mahogany kind of, those kind of trees they are mainly considering. But this particular question, biodiversity board is the people, they always do this kind of, which is the best one. That is what they are doing this part. So I will definitely ask them and find out which one is the best.
Yeah. Perhaps, when in fact, when people listen to the lecture, they may have a general question as, what we should encourage. But meanwhile, we also have to think that the trees, what is the water requirement and soil type. So maybe we may have also need to come up with a suggestion, like what tree in which part of Kerala, etc.
Yeah, when we decide on this species or the kind of trees we need to plant, whatever sir has told right now is important. The soil type and all those things they are considering and they are suggesting this will be more suitable for that particular location. So this is what they are doing actually. Right now it is with biodiversity board people are doing that. Yeah.
Anyway, so anybody else have any question? So if there are no more questions, I once again thank Sruthi for an excellent lecture on a very important topic. It's a very topical title actually that you have given, and I'm sure people might have enjoyed this lecture, and you have done justice to what you in your topic. Back to Aishwarya for the final one.
It gives me immense pleasure to deliver the vote of thanks on behalf of ICCS, to today's keynote speaker, Dr. Sruthi, who took time of her busy schedule and chose to be with us to offer this outstanding and thought-provoking speech on carbon footprint assessment and net zero commitments for a livable climate. I also want to express my sincere gratitude to our director, Dr. T.S. Pfizer, for his initiative in organizing this lecture series and also for his constant support and guidance. I would also like to thank all my colleagues at ICCS for their support, and also thanks to all the participants who chose to be with us today and attended this webinar with great enthusiasm and made this event a successful one. Once I thank you all for spending time with us. Thank you and have a wonderful day ahead.
Thank you.
Yeah. Before ending, those who are present, for future lectures, if they have any interesting, they want to know about a particular topic, I also welcome them to write me actually, so that we can identify a appropriate, speaker and arrange this lecture also. And similarly, if they want any other information within that, again, you can write me. Again, I just want to remind once again, we have made a notification. We have called, notified for the post of scientist in ICCS, which can be get from ICCS website. So you may please tell all your friends or those who people interested to join ICCS to work in climate change field. They can apply for that. So just for information. Thank you. Thank you, Shruti, and everybody those who are present. Thank you.
Thank you, sir. Thank you very much. Bye.
Thank you.